So our next example, the sum and product of two complex numbers are respectively 6 and 25. Find the numbers. So how to solve? Notice here the sum is 6, product is 25 and both are real numbers. So since the sum and product of two complex number are real. So if a plus ib, so the complex numbers are, let's say, so the complex numbers are, one is a plus ib, another one is a minus ib, because since sum and product are real number, when it is real, when the if a plus ib is a complex number, then another number must be its conjugate. Now if the sum is given here, if this one cancel out, the sum is given here 6. So this equal to 6. So 2a equal to 6, a is equal to 3. And product a plus ib and a minus ib is equal to 25. So a square plus b square is equal to 25. So b square is equal to 25 minus a square, a means 3 here. So 9 or b is equal to 16. Therefore, b is equal to, we can put plus minus 4. So what is our complex number? Therefore, the numbers are a plus, let's say 3 plus, when I take b is equal to 4, so 4i, or 3 minus 4i, or 3 minus, let's I have written here, sounds good. So 3 plus 4i, 3 minus 4i, when b is equal to minus 4, it becomes a 3 minus 4i and here 3 plus 4i. So the ultimate, the numbers are, the complex numbers are, one is 3 plus 4i, another is 3 minus 4i. That's it. So the concept is, since the sum and product are two both are real number, that means the complex number, they are conjugate to each other. So if one number is a plus ib, then another number is must be a minus ib. Then I just put applying the given condition, sum and product. From here I just find a and b. Then you substitute a in place of a and b, and you get the two complex number. So our examples for any two complex number z, find the minimum value of mod of z into plus mod of z minus 1. So from the modulus property we know that mod of z minus 1 is greater equal to mod of z minus z minus 1. So from here we get 1. So what is the minimum value of this? Therefore, the minimum value of mod z plus mod of z minus 1 is equals to 1. It's a very simple problem. For we need to find out the minimum value of mod z plus mod of z minus 1. How to do this? Mod of a plus mod of b obviously greater equal to mod of a plus b, or a minus b in case of mod of a minus b is less than equal to mod of a plus mod of b. I just applying this formula, you will get z minus z cancel out, minus minus plus 1. So the value is greater equal to 1. That means its minimum value is 1. Now our second question is here. The question is, if a is equal to cos. So our next examples here, a is equal to b equal to c equal to given. A is equal to cos alpha plus I sin alpha, b is equal to cos beta plus I sin beta, and c is equal to cos gamma plus I sin gamma. Here a plus b plus c is 0 and we need to prove a square plus b square plus c square equal to 0. So before going to any process, let's say what is our formula for a plus b plus c whole square? The formula is a square plus b square plus c square plus 2 into ab plus bc plus ca. So a square plus b square plus c square, that means a plus b plus c whole square minus 2 into ab plus bc plus ca. So okay, so we need to prove a square plus b square plus c square this is equal to 0. That means we need to find the value of a plus b plus c and ab bc ca plus. So first a plus b plus c, I just substitute a is equal to this, b equal to this and c equal to this. Substitute here, you will get cos alpha plus cos beta plus cos gamma plus I into sin alpha plus sin beta plus sin gamma. So this is equal to, I just write in single notation summation of over cos alpha and here summation of sin alpha. Summation of cos alpha means cos alpha plus cos beta plus cos gamma and summation of sin alpha means sin alpha plus sin beta plus sin gamma. Given a plus b plus c is equal to 0, so put it here 0. Now compare both sides, we will get cos alpha is equal to 0. Here also not imaginary part, that's why summation of alpha is equal to 0. So we already have a plus b plus c is equal to 0. We need to find out this. Now to get that particular term, what we will do, let's say 1 by a, we need to find out 1 by a, 1 by b, 1 by c. So 1 by a, this is equal to cos alpha plus I sin alpha, and that can, if we rationalize it, cos alpha minus sin alpha by cos alpha plus I sin alpha into cos alpha minus I of sin alpha, or 1 by a is equal to simply cos alpha minus I of sin alpha whole divided by a plus b, a minus b, that means a square minus b square. I squared means minus 1, so minus minus plus 1, here sin alpha, so this becomes cos alpha minus I of sin alpha. Similarly for 1 by b and similar for 1 by c. So 1 by a plus 1 by b plus 1 by c can be written as cos alpha plus cos beta plus cos gamma minus I into sin alpha plus sin beta plus sin gamma. So this is equal to, if you LCM it ABC, you will get BC plus AC plus AB, and this is equal to summation over cos alpha minus I into summation over sin alpha. So ABC plus AC plus AB, this equal to 0, since summation over cos alpha is equal to 0, summation over sin alpha is also equal to 0. That means the value is 0 here. So ABC into 0, that will give you 0. So we get BC plus AC plus AB equal to 0. So therefore a square plus b square plus c square, that means a plus b plus c whole square minus 2ab plus bc plus ca. So both the values are 0, so this becomes 0. Therefore a square plus b square plus c square is equal to 0. Hence proved. So in that particular problem, we are given z is equal to x plus iy and z minus I by z minus 1 is equal to ip, then show that this. So how to solve? So z minus I by z minus 1 is equal to ip. Now z is equal to x plus iy. So if we put x plus iy, then x plus y minus 1 into y by x minus 1 plus iy is equals to ib. So x plus y minus 1 into I, if you multiply this, so minus by ib into iy, I square by, so minus by plus ib into x minus y. Now compare both sides. compare both sides, x is equal to minus of dy or b is equal to minus of x by y, and here y minus 1 is equal to b of x minus 1. So b is equal to y minus 1 by x minus 1, and these two become same. So therefore my x by y equal to y minus 1 by x minus 1. So minus of x into x minus y 1 is equal to 1 in y into y minus 1. So minus x square minus minus plus x, this equal to y square minus y, or x square plus y square minus x minus y is equals to 0. But we need to prove x minus half whole square, y minus half whole square. So how to do this? I just write x square minus, in place of x, I just write half into x. So 2 to cancel out, we will get x. So a square minus 2ab plus b square. So I just add 1 by 4. Similarly for y square minus 2 into 1 by 2 into y plus 1 by 4. So I will add 2 1 by 4. So 1 by 4 plus 1 by 4. So 2 into 1 by 4, that means 1 by 2. So I need to balance it. So I just subtracted minus half, and you will get this term. 2 to cancel out, 1 by 4 plus 1 by 4 means 1 by 2 plus 1 by 2 minus 1 by 2 cancel out each other. So we'll get this one. So from here we'll get x minus half whole square, and from here we get y minus half whole square minus 1 by 2 equals to 0. So this equals to 1 by 2. So proof. So what I am doing here, first of all, z minus I by z minus I is equal to IB. Put z is equal to x plus IY. If you put x plus IY minus I just take plus I common here. And z is equal to x minus y plus IY equal to IB. Now multiply by 1 into this, IB into this, you will get this value. So compare both sides, real and imaginary part. You will get x is equal to minus by and y minus 1 is equal to b into x minus 1. So this b and this b same, so that's why this is equal to this, and just simple calculations you will get this value. Now our next problem, given x plus iy is equal to this, you need to show like this. So x plus iy given x plus iy is equal to root under a plus ib by c plus id. You need to that particular term, I mean x square plus y square. So I just squared both sides. So x is x plus iy whole square. This is equal to a plus ib by c plus id. Now x plus iy whole square can be written as x plus iy into x plus iy. This is equal to a plus ib by c plus id. Now take modulus on both sides. So x plus iy into x minus x plus iy. This is equal to mod of a plus ib by mod of c plus id. Again mod of xy, that means we can write individual mod, that means mod of x plus iy into mod of x plus iy. This is equal to mod of a plus ib whole divided by mod of c plus id. Now mod of x plus iy means we can write root under x square plus y square. Here also we can write x square plus y square. This is equal to root under a square plus b square whole divided by root under c square plus d square. So this into this means we can write x square plus y square. So this is equal to root under a square plus b square by root under c square plus d square. Now squaring both sides, we will get x square plus y square whole square. So this is equal to a square plus b square divided by c square plus d square. So proved. So in these examples, we need to find the value of 1 minus omega plus omega square, 1 minus omega square plus omega to the power 4, 1 minus omega to the power 4 plus omega to the and dot 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 like this way to n number of terms. So we know that the property 1 plus omega square is equal to 0 and omega q is equal to 1. So 1 minus omega plus omega square, 1 minus omega square plus omega to the power 4, 1 minus omega to the power 4 plus omega to the power 8. What will be the next term? If you see the series omega square minus omega square omega to the 4 minus omega to the power 4, so we can write 1 minus omega to the power 4 plus omega to the power 16 and so on to n terms like this. So 1 plus omega square. 1 plus omega square means here we can write minus omega. 1 plus omega square is equal to minus omega. So 1 plus omega square minus omega minus omega. So here we get minus 2 omega. Similarly, from here omega to the power 4. Omega to the power 4 means we can write omega q into omega. That is equals to omega. So 1 plus omega. 1 plus omega equal to minus omega square. That's why we can write minus of omega square. Similarly, 1 minus omega to the power 4 plus omega to the power 8. So 1 minus omega to the power 4 means omega and omega to the power 8 means omega. Omega to the power 8 we can write omega to the power 6 into omega square. So 1 into omega square. Omega to the power 6 equals to 1 because we can write omega cube whole square is equals to 1. So 1 minus omega plus omega square, this term. So again 1 plus omega square is equal to minus omega, here minus omega. This will become minus 2 omega. Similarly, 1 minus omega to the power 8 plus omega to the power 16. So 1 minus omega square and omega to the power 16 can be written as omega cube whole to the power 5. 3 5s are 15 into omega. So this is equal to omega. So again 1 plus omega means minus omega square. So this is equal to can be written as minus 2 omega square. And continuing this process to n terms. I just apply the formula here 1 plus omega square equal to 0 and omega q equal to 1. From here you can evaluate easily omega, what is the value of omega to the power 4, omega to the power 8, omega to the power 16. We can easily evaluate. So this is equal to now minus 2 omega into minus 2 omega square. If I consider this a single term into minus 2 omega into minus 2 omega square, and that will be repeated since the whole term is 2n terms. Now if I consider the pair terms, then it goes to n terms, n number of terms. So this is equal to 4 omega cube into 4 omega cube dot 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 till to n terms, and this equals to 4 to the power n since omega cube is equal to 1. So 4 into 4 into 4 dot 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 n terms. So this is equal to 4 to the power n, and that becomes 2 square whole to the power n or 2 to the power 2n. So that is our answer. It's a very simple problem. So the concept is like I just apply this formula, then you will get this term. Now I take pairwise term, so it goes to n number of terms. So 4 omega cube to n number of terms, n number of terms. So then here omega cube is equal to 1. That's why 4 into 4 into 4 to n terms. So 4 to the power n. This equals to 2 square whole to the power n, and this equals to 2 to the power n. Our next example, here if x is equal to omega square minus omega minus 2, then evaluate this one. X to the power 4 plus 3x cube plus 2x square minus 11x minus 4. So given x is equal to omega square minus omega minus 2, Therefore, x plus 2 is equal to omega square minus omega. So, x plus 2 whole square. This is equal to, we can write omega square minus omega whole square. So this equal to x plus 2 whole square, a square minus 2ab plus b square. So x square plus 4x plus 4 omega to the power 4, that means omega minus 2 plus omega square. Since omega to the power 4 is equal to omega cube into omega, this equals to omega. Or x square plus 4x plus 4 is equal to omega plus omega square. Since we know that 1 plus omega square equal to 0, so omega plus omega square equal to minus 1. So minus 1 minus 2. So x square plus 4x plus 3 plus 4, so 7, this equals to 0. Therefore, x to the power 4 plus 3x cube plus 2x square minus 11x minus 4. This, how do I write this? I just divided this by this. So this is a factor of this. I just how to do this? Simply you just write x square plus 4x plus 7. First term. Now the first term is x to the power 4 here. You just write x square. I just balance, or I just write this equation using this factor. Very simple. First term, I just write first term here, x square into x square. So x to the power 4 plus 4x cube plus 7x square. So x to the power 4, x to the power 4 is there. Okay. Our next term is 3x cube, but here 4x cube. So we need a term like minus x cube. Only you focus on cube term. So minus x cube, for that I just minus x into, I can write x square plus 4x plus 7. So minus x into x minus x cube minus 4x square minus 7x. So 4x cube minus x cube minus 3x cube. Here 7x square minus 4x square. It becomes 3x square. But we need 2x square. So we need a term like plus x square. 3, no, we need a term like minus x square. 7 minus 4, 3x square minus x square. So 2x square. Again, simply I just write minus 1 into this. So because in that case I am focused only x square term. We already balanced cube term, now x square term. So 7x square minus 4x square. 3x square, but here 2. So we need to a term like minus x square. So I just minus x square minus 4x minus 7. So x square is balanced here. Now minus 11x. So here minus 7x minus 4x minus 11x. Okay. And here minus 4, but here minus 7. So we need to put it here plus 3. So we need to put it here plus 3. So this is equal to, this value is 0. So x squared into 0 minus x into 0 minus 0 plus 3. So what is the value here? The value becomes 3. So this is your answer. So what is the value here? This value is 3.